So after all this, let's have a look at the project that I have created. First of all, I open my Anaconda Navigator and dive deep into the Jupyter notebook. After diving, you can see I've given the title here. As I click, I can give it the title COVID Analysis Project 2020 Asia University Semester. So this is a small dataset analysis. It's a small sample data intended for Python usage and can be used for a project. We will be working on some old data as new data isn't sufficient yet. As you can see in the current times, it's bleakly on the graph, so we will be using an old data the majority of things. There were some problems in my PC, as I have written here, with my SSL objects with my antivirus. So I have not used online data, but I have used a uh, predefined file that I have saved on my PC. The data used here is till 29th April 2020 and has records as on 29th April 2020. So you might be wondering where this file came from. Well, this file is from a trusted site called Kaggle. Kaggle is an official website that has a data science libraries and that has a data science library and many other things. You can do most of the things on Kaggle requiring data science and get a plus certification from this site. Be sure to visit it if you want to learn more about data analysis. So we will first analyze the data using the Python pandas data frame. So in this project, first what I've done is imported pandas as PD. We done here. This goes smoothly. That is, now we are about to import data. I had downloaded the data as a CSV file here. As you can see, this is a CSV file. So we downloaded this data and now we are importing using data is equals to pd.read CSV. This is the old command that I told you. And if I wanted to tell you, we will be taking here, right clicking, copy as path, and if I wanted to just show you here, if I directly paste it and click here as run, this will give an error because this is Unicode. To read such big data files, we use this R function and then click it as run. Now we are good to go. To have a look or just to have a display or a print function, we give here as data. We run this thing, we get the data intended. It also shows that it has 321 rows x 6 columns. That is, there are 321 rows 0 to 320 and 6 columns 1 2 3 4 5 6. If we want to explore the data more further, if we want to count, so we can say that the date function is 321, the state function here is only 140 and all the else are 321. You can see that there are some non-available states. These are just the regions having no major states. So if there are null values, there are that is, it means there are missing values. It means that they are not in the form of decimals or numbers. Like, you cannot say that this 0 is a null value because this is still a number, this is still a defined thing. But if there is nothing defined, that is known as null. So here we check it as data dot is null, and when we click it as run, what we get here is all the things. True means null and false means it's not null. So as you can see, this is not null, so it will give a false. That is, all the data things are given and date columns are filled up and we don't have a null value in it, but only null value is provided in this state type of array. So when we have this state, you can see it's all true, meaning that this is a null type. So if we wanted to have the number of null values or the sum of null values in a particular parameter, we type this data.isNull.sum and click here as run. In date, we saw it that all things are false. In state, we only saw the top layer of the true null values, but we didn't know the actual number. So this function here gives the actual number that don't have a state here, so it's 181. So this is a good observation that I would say. Next we are upon to do something serious. So we take it here as Seaborn library. Now Seaborn library is basically for performing major graphical functions or major functions that are used by data analysts in most of the things. So, and next in this one we import the matplotlib here. Now this is the SNS heat map data null. So we can see the data 181. We saw that there were 181 states that have the null value. So under the null, this is a heat map. In this it shows that all those things that have 0 have somewhat a pink kind of color, I would say. So under state we can say that this is a pink color here. That is, all these values until 181 approximately according to this graph are null. This is if sometimes there is an error in Mac users that this function doesn't run and doesn't show quietly. So what you can do this is you can use the function plt.show here so that it shows the function here. So let me write, if it doesn't the outputs are basically the same, but it is used for a more visualized and a more detailed type of analysis. So on Kaggle, for this particular data set, the small data set, there were some basic questions and I took them as variables and tried to solve them. So the first question was the number of confirmed deaths and recovered cases in each region. So data head 3, this, what does it represent again? It represents the top three data sets of this, that is not the top 3 are arranged accordingly. This is top 3: Afghanistan, Albania, Algeria. It shows the top 3. That is, we are good to go. This, it is just used to basically see that if the data you are proving is the correct data set or not. Next we move up by group by region. So what it does is it only gives an object, but what it's doing is it's grouping the things that we want by region, and if we want it by sum, we print here dot sum function here and click it as run. So let us see a more further look, that it eliminated all the date and state columns that were useless to us at this point, and we just wanted the region here and the sum of the columns that actually have a value, decimal values to it, that is 1939, confirmed cases, deaths and recovered. It shows that now we have 187 rows and 3 columns. We are basically shredding the data, and as I would say for data analysis, the second step was filtering data, right? So we are filtering the data accordingly and substantially. Next, if we want to see the top 20 by sum, we use the data dot group by region dot sum, that is we are printing the sum up till here, and then dot 100. If we want more functions, we just add functions and this dot functions. So if we want to do substantial, or we can say consecutively different functions, we can use the dot function here and perform many functions in a singular line. So now we get the top 20 here: Afghanistan, Algeria, Algeria, and all these. Next we are grouping the data by region and confirmed and using the sum of it. So when we printed data.group by region, and this confirmed is a list, this region was a tuple, but this confirmed was a list. Where it was stated, it was originally stated in the question statement. I will have to find it, but it was stated that the region is a tuple statement and the confirmed is interchangeable, that is the values in confirmed can be changed, and we are printing the sum of it. So we get the confirmed cases here. The name is confirmed, length is 187 as we had the number of rows here, and data type is 64, that is it, although it is storing without decimal points, no floating values, it can store decimal values. So this data type is 64, that is a float is used. Moving on, we are trying to sort the values that we have grouped here as sum in a descending order. So we take the previous function here. Let me just erase it to show you. We are taking this previous function here, copying it, dot sort values extending is equals to true. Let me first print it as false. So when we print it as false, this means that it should be in descending order. So we see that for confirmed cases here, we get used as 1039, and the most number of cases it used as, that's a drastic number, I might say. It's a data analysis of 29th April 2020, but still to say it's a drastic number, approximately 10 million here. And till the Yemen, that has the lowest number of things. If we printed extending is equals to true, we will get in an ascending order, that is from smaller to bigger, and extending is equals to false, that is descending order from bigger to smaller. By default, if we do not add this extending is equals to true, it is stated that by default it is extending is equals to true. So we add extending is equals to true, or we do not add, it's the same thing, but for your reference I'll just add it. Next up, what we are doing is we have taken extending, we have to take the in descending order. So we take this value here, we just copy paste it and print the top 10 here. So as you can see, we have printed the top 10 countries that at the time of 29th April 2020 have the highest number of confirmed cases in total. In the next data block, you can see that we have grouped the region by confirmed and also recovered, that is we are grouping the region tuple region with two lists, confirmed and recovered, and using the sum of it. Now as you can see, there's an error between that, but also we are getting an output. That error basically says that we are implicitly converting a tuple of keys to depreciated value, that is we should use a list instead, but we are using a tuple to print two values. It may not harm small codes, but it basically does harm a large codes. So keep that in mind, and if you have a larger data set and don't want to mess around with it, you should have a future warning and just stay safe and be careful out there. So here we have confirmed and recovered rows. So we have only two columns here, confirmed and recovered, and this region is a tuple, and we have 187 rows as previously stated. So this was the original question, that we had to number the confirmed deaths and the recovered cases in each regions. So this was the answer that was originally answered. I confirmed it through the answer that was given as correct on the Kaggle website. So the next question here was removing all records where confirmed cases were less than 10. So we again check if the data is working properly. So we print as data.head is greater than 2. Yes, it works properly. Now we display that data.confirmed is less than 10. So basically what it does is it basically represents or displays if the data you are printing is less the confirmed layer, whatever data have confirmed layer is less than 10. So whoever have that as false, it will print it as false. Whoever has it as true will print it as true. Now we can't see all the data here, but we can see it if we perform it as data in data confirmed. Then we'll see it in a more data type format, like now we can see that all those countries that have confirmed cases less than 10, you see all these are all lined up and in the form of data frame. So now we can perform the function that we were asked to remove all these records accordingly. So what we are doing is data and this negation value, this is not equals to, suppose if this is given, we say that this is a bar. Now bar is basically a boolean algebra type that is taught in computer language, if you must say. So this is a negation value. Now this data is, now the data that we are seeing here consists confirmed cases greater than equal to 10, and this has negated all the data confirmed less than 10. Now a very important note, in this data we are just representing it, we are not altering it, we are not changing it, or we are not storing it, we are just trying to represent it. As if we print data, we will see that there are confirmed cases less than 10 because it has all the rows. So if we want to remove it in the original records, we have to store data is equals to data and this command. So what it will do is it will remove all the records from less than 10, and when we print now data, you can see 304 rows, that is 17 rows have been removed from this thing, the 17 rows that were originally these 17 rows, they all have been removed from that original data set, and now the data set have changed. So we completed this part of the question. I have just taken here as top 20 data head to show that all things have been done accordingly and there are no confirmed cases less than 10, all are greater than equal to 10. As I might say that it's only for the confirmed cases and not for the deaths or recovered. You can perform it as I have done in this code. So this part of code is done. Now the next question is region in which maximum number of cases were recorded. So we are now improving, or we can say we are now progressing towards the next session or the next question that was provided to us. So for the next question, it is not stated that do this analysis on the previous data stored. So for the new data stored, what we have to do is we have to again write, or we can say we have to originally execute this cell, the first cell here, so that the original data file is again loaded and we don't have to deal with all this crap and whatever happened in this removing and altering data. So we print the data here to ensure that we have again 321 rows and all the 6 columns here. We print the top 2 data heads so as to ensure that the code and the block cell is renamed properly. We use the data group by region, and as it is stated maximum number of cases, we have to perform confirm.sum sort values ascending. We see that for descending when we perform a descending value function, the region with the topmost confirmed cases pops up to the first, which is the US. And to confirm this, we just print the top 20 functions here. As you can see, these are the top 20 having the most number of confirmed cases in descending order, ranging from 10 million to 21k. So this is just a region in which if we want to represent the top first, the first one, we can just print it as head is equals to 1, and you can see we got US that has the topmost we can say the confirmed cases for that region on the date 29th April 2020. Next question was confirmed deaths and recovered cases reported from US till 29th April. So we again check the data at the top with 2 so as to confirm that the data is again working properly. And for anything, if we want to check any data related to a particular region, we use data dot region equals to US or India or Indonesia or any other country that we might want to say. Region name as to specify a type. So we can see when we type US and when we click it as run, we can see that the region US with all the states such as Alabama, Alaska, Arizona, Arkansas, California, all these confirmed cases, and we have the data set to be performed on this region US. So now we can proceed further. And we can sort the entire data with respect to number of confirmed cases in ascending order. So to check again, we print the data top 10 elements here. And the sort, now this is a new function, data.sort values by is equals to confirmed. The sort values function is used to perform the sort values, and by is equals to confirm means that we are using the confirmed column to sort the things, and ascending is equals to true. That is, we will be performing the ascending function. The data should be in ascending order for this data type. We are using the and as we click run, what do we get here? The confirmed cases start from 0, that is from the US recovered region, from a Canada recovered state, to the most number of cases in US New York, that was approximately 2 million or 3 million, we can say. This was the maximum number. So this has been ascended, or we can say this has been sorted. The data has been sorted according to the ascending order of confirmed cases in the data set. Next, if we want to have a more detailed function here and all these dot lines, we can print the top 50, and you can see here that the confirmed cases top 50 have been printed here. As you can see, the top 50 have been printed here for this examination. I'm just performing a small scroll up here. So we move on to our next line, that is sorting entire data with respect to number of recovered cases in descending order. So we again print the top 10 again. It's become a ritual now, so as to check that if the code is running properly, we get the value, and then we print the recovered case. Sort values by recovered. Ascending is equals to false. We have to just sort the things. So we get here, we have sorted the things. Recovered is in descending order, that is the largest one here and the smallest one below this, and we have got all the data sets here. Now this is a function here, data.columns. Let's have some visualization here. So data.columns is used to see what columns are we provided with in the data set. So for this data set we are provided with the column date, state, region. These both are tuples that don't have an integer value, so these are useless for matplotlib visualization. And this date is almost the same for everything, so we don't have to use that. So the main basic focus for this project, the ending project, would be confirmed, deaths and recovered. So we have this function data.describe. So what it basically does is, it may not be useful for these small data types or data sets, but it's basically more useful or most useful in large data sets, and we have total number of cases, hospital beddings, and there are many parameters. It's useful in those conditions and those scenarios, but here we can say it's not quite useful, but it's just for your recommendation that if you want to see that your data is in perfect form, and if there are any floating values in the data that are not being represented in this, we can use this function data.describe here. So let's have some visualization. So first we are using the scatter plots function. So we have already, let me say, where did I import? We already imported the Seaborn and the matplotlib here. Let me show you again. Import Seaborn as SNS, import matplotlib.pyplot as PLP. So we use the sns.rel plot, the relating variable plot, and the x variable, the x-axis should be confirmed cases, that is this parameter, and the y-axis should be death cases, and data is equals to data. We use this function that data is the same as the data or the variable we are using here. If it was df or it was d, we will use data is equals to df or data is equals to d. We scroll down. Let's have a run again. So it takes a quite while if you have a slow computer, but if you have a fast one, you can see this is a haphazard way of, or you can say this was not a quite clean data set that we have performed the function upon. This function is not scattered, but it's basically focused onto this, when the confirmed cases are mostly here, and there were only some cases in 2020. If you might remember, there were only some countries that had the topmost regions, such as the US only had the topmost counting of coronavirus cases. Or yeah, so this is the scatter plot function that I would say. If we wanted to have the x as confirmed as and y as recovered, we can do this here. as sns.rel plot x is equals to confirmed y, and when we try to run it, it shows this function a different graph from the depth function here. But basically what we are doing is we are plotting a visualization on what we are doing. If you have a clean set of data, you can use these functions to perform some variable functions or some graphical visualizations of those. Now this line is used to add some hue to the depths. That is, it will add x is equals to confirmed, y recovered, and hue whenever there is interaction between a depth and the any of the following dot that have been made on the originally made graph. So here is some legend, you might refer to it. Next up is a more detailed visualization here. Now we will use a pair plot of data. This basically does is it pair plots a pair grids, the pair grid type of data, and it creates a graphical value that is more importantly used in functions in which we don't know all the variables, we don't want to mention all the parameters, but we want a relatable graph. So when we use this and enter run, it takes quite a while, give it quite a while, and as you can see we have all these functions: confirmed, confirmed, confirmed and confirmed, confirmed and deaths, confirmed and recovered, deaths and confirmed, deaths and deaths, deaths and recovered. So you might see that these are a blank just because the x and y axes are the same, so it doesn't have to respond to those things. If you want to just have a recheck of your data, you can always perform by taking some values from this originally made graph and have some recheck here for the approximate values, because you cannot have some approximate values with these dots here. To perform a phase grid here, or we can say a line graph here, we can use rel plot kind of line, and data is equals to data. So let's have a run through it, and this will perform the kind of line. If we want x-axis as confirmed and y-axis as recovered, and we want the line graph, we can again use it and run it here, and we get this haphazard manner of line graph here. I've done some experimenting using these deaths and recovered, confirmed and recovered, confirmed and dead, to see if the line graph is actually running for all data types, or is there any function or any error running through it. Next up we have the categorical plots. Now the categorical plots are basically a more modern type of approach to look at the data sets. So we use the function sns.catplot. We take the x-axis as confirmed, y-axis is dead, and the data is equals to the data variable in which we have stored the data. Now by this visualization, you can conclude that we are on the right data set. Why? As you can see, the confirmed cases and the deaths have an exponential type of graph, which means in the first phase of COVID, as we saw that there was an exponential graph, because first it was slowly and suddenly it started to boom and then it went again. So for the first half, this was an exponential, and thus we can conclude that we are on the right path, that is, we are on the right data set. If we try to confirm it with confirmed and recovered, there will be a realization that the recovered and deaths were almost the same, and we are again performing it successfully. So this was just a small data analysis project done by Ariman here, Ariman Adir Singh, and I hope this is a well project made and helps you in all the learning the basics, because if I would have gone through some haptic or some, we can say, complex type of data sets as I saw on the internet, it would be difficult for you to understand. I did it all for you. So we can say that this is the most basic and most advanced type of thing that you can learn in this era for data analysis and data science projects. Thank you. If you want to know where I have stored the data and all this, all these things and all the code that I promised, I have uploaded it on my GitHub page here. And the pandas one, the numpy and matplotlib were not as important because it's just a mathematical thing. But the pandas and the COVID-19 whole project, along with the Jupyter notebook, the Pi notebook, and also the CSV file have been uploaded on my GitHub. So if you want to check it out or want to have some help over it, you can surely have. Thank you, and it was a great time making this project, this videos. Hope it helps for you, for me, and everyone that sees to it.